Okay, class, welcome to another day of science class. What we're going to do today, class, we're going to do a lab, and our lab is going to be on convection currents. Does anybody know what a convection is? Anybody? Anybody? Okay, well, no response, so you must not know. A convection is when there is a difference in temperature, okay? So we got warm air versus cold air. Now, right now, we are just into fall, just starting fall, and you might have your heat on in your house. Who can tell me what part of the house is usually the warmest part of the house? What part? Anybody? Upstairs. That's right, upstairs. Now, come on here, helper. Here's my helper again, everybody. Everybody say hi to my son, James. He's my helper again. Okay. Now, we want to talk about convection currents. So, we just said that convection currents happen when there's a difference in temperature. And James, you said that the warmest part of the house is what?
Upstairs. Upstairs,
okay. Because what happens to hot air or warm air? It does what? It rises. It's absolutely very good, very good. And cold air does what? It sinks. That's right. It drops, it sinks. Very good. So scientists think that convection currents is what causes the mantle, the magma in the mantle to circulate and therefore move the plates. Let's do a little review first. Okay, let's look over here first, okay? So we've been talking about plate tectonics, and I was really happy with some of the responses that I had today in class when I asked you some questions about plate tectonics. But anyway, the first thing I want to talk about is that we know that the earth is broken up into plates, right? And these plates do what? They do what, everybody? They do what? What do plates do? They move. They move. People. They move. Now, Albert Wegener, back in, I don't know, some 1800s so, he noticed that, what's that? Where's my, he noticed that Africa and South America, they seem to have fit together. He noticed that it looks like they can almost be together. So he started thinking about, I think that at one point in time, the continents were all together in one landmass. And what did he, I want to get the answer, And what did he call that landmass, everybody? What did he call it?
Pangea.
He called it what? I can't hear you, son.
Pangea.
He called it Pangea. So Albert Wegener said that, right? Pangea, 1880 to 1930 is when he lived. It just came to me again. Okay, so Albert Wegener said that about continental drift. And then we just did an activity a couple days ago relating to plate tectonics. So here we have, over here, continental drift. And over here we have plate tectonics. Now, you can tell here that we have these continents here, right? But it's just not the continents. Scientists realize that it's just not the continents that are moving, okay? That the plates are moving, and the plates do not only contain the crust, but it goes down into the mantle, right? Into the mantle, the upper part of the mantle. So we have continental crust, and we also have oceanic crust, okay? We have continental crust and oceanic crust. Anyway, so you can see here by the arrows, what's happening here? Can you focus on one of those for me, DJ? Which one are you gonna focus on?
Talk about this.
Okay, let's focus this one. Good. So we have the North American plate, and we also have the Pacific plate. You see how these arrows showing, what are they showing? The way they move. These plates are moving this way, so they are going to eventually do what, you think?
Crash.
They're going to collide. They're going to collide. They're going to crash. Collide. Good. So when plates collide, things happen. Things happen when they collide. Guess what? How about this? How about this one? Let me see. Let me find one that they're separating. How about here? How about the South American plate and the Antarctica plate? The Antarctic plate. What's happening here? They are doing what?
Diverging.
They're diverging. Very good. It's called a divergent boundary. Very good. Say it again, young man.
They're diverging.
Divergent boundary. They're separating. And things happen when things separate, okay? Now, I don't want to give out any clues. I'm not going to do that today because you had that yesterday in class, right? Now, so this is what we're going to do today. We have a lab for convection currents. Remember, scientists believe that the magma in the mantle, because of the differences in temperature, they believe that that is causing the plates to move. We're not sure. They're not sure. Okay, but this is what their theory is, okay, for now. The theory can change in what, 200 years, 100 years, whatever. But right now, this is the theory. Go ahead, James. Snap it in. Very good. Okay. Now what's next? Into the vial. Only the vial, the little small vial. There you go. Okay, very good. One drop. That's it. That's all we need. Okay, what's next? Oh, you know what? I'm sorry. Let me just first tell you what the materials are. We should always do that. We have beakers. We have a syringe. We have a vial, a cup. Obviously, you know, the cards. 5 milliliters. Okay. So pull up to 5. Oh, that's a little bit more than 5. That's more than 5, man. The bottom of the cap. Keep going. Okay, that's about 5. Yeah. That 5? Yeah, it looks 5. Mm-hmm. Yeah. Okay. Yeah, I'm not gonna tell you. Okay, I'm sorry. I'm supposed to say. It says use a syringe to carefully fill the vial with about 5 ml. So you're not gonna have all. You're not gonna use all 5 milliliters of warm water. So you can put that in a little hole. In a little hole. See that? No. Yeah, in the hole. There you go. Okay, Jane. Yeah, go slow because it's gonna be. You wanna go all the way to the top though. All the way to the top. Look, you do a tiny bit more. There you go. That's perfect. That's perfect, young man. Okay, what's next? It says cover both of the holes in a 2-hole cap with 2 fingers. Go ahead, you got 2 fingers. And have one person in your group slowly add cold water to set up. So class, we're putting warm water in the small vial, the small one that has a red dye in it. And now we're gonna carefully add cold water to set up until it's almost full. So here we got cold water, class. It's cold water. So it's almost full. I'm gonna pour. You got to cover those holes, Jay, so it won't come out. Okay. Now it says remove your fingers and observe what happens. Move your fingers. Okay, you see what's happening there? What's happening there?
Looks like it's going to the top.
It's circulating. Okay, so the warm water that's inside the vial is doing what? What do you think it's doing?
Rising.
It's rising. Okay, and what about the cold water? Is the cold water rising? No. Okay, so you can see what's happening there.
Cool.
All right, so we're gonna look at it says right here. Observe what happens from both the side and the top. Can you get the side and top of that, DJ? Move this out your way. And we can actually see the circulating. I can see the circulating. Can you see the circulating? Yes, you can actually see that happening, okay? So remember, we are talking about convection currents. Now it says record your observations as trial 1 in your science notebook. So class, you're gonna have a paper like this, okay? It's on the lab. It's on the site, and you're going to see we have some questions relating to the lab. But right here, this is where you're going to put your data. So here is trial 1. Warm water was placed in the vial, in a smaller cup, in a smaller vial, and cold water was in the cup. And you're going to record what did you see happening. You just saw it. You just saw it. What is happening there? You're going to record that right there in the cup. I mean, on the dad table. Record that on the dad table. Okay? Now, it says, so you're going to draw, you're going to draw the cup, class. See here, it says draw what happens, draw the cups, draw arrows to demonstrate what happened. So make sure you do that for trial 1. Okay, trial 1 is done. Do we need more time for trial 1? Do you want to show that one more time, DJ? Trial 1? This is a few minutes. There is a difference now, there isn't it? There is a difference. You can, yes, it's sinking. What Why do you think it is sinking now? Somebody tell me why you think it's sinking.
It's getting colder.
You think it's getting colder? Okay, absolutely. Okay, now it says after a few minutes, carefully remove the vial from the cup. Describe the contents of the vial in your science notebook. Is there any difference, you think?
This?
What happened to inside the vial? Anything different, James? We don't really know because we didn't see it beforehand, really, right? Now it says empty and rinse the vial, the cap, and the cup. So we're going to come over here. I'm going to empty all this. So now we're going to do it again. Okay, so here we go. I'm putting 1 drop in here this time, right, James? You did it for last time, so I'll do it. We like to share. See, this is what you do. You get back to class, guys. You share. One person does not do it all. 5 milliliters of cold water. We are switching it now, class. Before we have warm water in the vial. Good. Excellent. Okay. Now, before we pour the cold water on your hands, right? So put your fingers over there again, James. And this time we're going to pour the warm water. This is warm water, class. Okay. You can release your hands like you did before. Okay, do you see a difference? Let's see. Now remember, we have cold water in the small vial, and we have warm water was poured in the big cup. Okay, the cold water is not coming out of the vial. Okay, absolutely. And what's happening to the warm water? Is the warm water rising? We don't know. I mean, we can't tell because we don't have any food color in that part, right? So the warm water can't go where the cold water is, so there's no difference there, right? Now, what do you think would happen if I let this sit for a long time? Is there gonna be a difference?
Yeah.
You think so? Like, what do you think would happen?
It would even out.
It would even out. Okay. So go ahead.
Because they would become the same temperature.
Okay. So are we gonna see a convection? You think ever in this cup?
Yeah.
I don't think so, because the warm water is going to cause the cold water to get a little warmer, right? And the cold water is going to cause the warm water to get a little colder. So like you said, it's going to equalize the temperature. But the inside the vial, it is never going to be warmer than it is inside the cup. So we're not going to see a convection happening here. Does that make sense, class? Now we can sit here all day long and we're not going to see a convection happen. So I'm going to just continue to go over the directions and we'll come back to that in 1 second. So you know how to do a lab report by now. We have done like 3 or 4 lab reports in this class already, but let me just recap. Obviously your name goes here. You're going to, the title of it is How Does Differences in Temperature Cause a Convection Current? You're going to answer this one question. When does a convection current occur? And then you're going to go on. Here is the problem statement or a question. You know how to write hypothesis and if-then statement. If you don't do it like that, you're not good for credit. And then you need to identify our variables, okay? What was the same? What was the same? Now, think about it. What was the same when we did this? And what did we change? What was our independent variable? What did we make different? It should be very clear what was different, okay? If you don't know, look at the trials, okay? And then what was the response? What happened? Materials, procedure. And then you're going to tell me some qualitative observations. That means what? I'm not going to tell you. You should know what that means by now. And quantitative observations. You should know what that means. Quantity, okay? And then you're going to give me a paragraph. So that's your assignment for the day, class. Make sure you get it done. You have at least an hour to get it done. So make sure you finish your assignment. Look at me now, DJ. Okay, class. So that is your assignment. You have at least an hour to complete it. Make sure you complete the lab report and the analysis questions and turn it in. Class, I just want to say thank you to our helper. Thank you, James, for helping us once again.
You're welcome.
All right, class. We'll see you later.